Hello, everybody. So, day 2 of database management systems, 110, DBMS 110, intro to data analytics. So, the word introduction is in the class name. There's a lot of concepts and vocabulary stuff. And I'll cite heavily. There is a sort of a vocabulary lecture today, right at the beginning of the semester. We got to make sure everybody knows the right words. So, for the rest of the semester, we can use all the proper terminology and nobody's confused. The book had a good covering of it, but if anybody's read that so far, you might have noticed that it was very technical. Very, very technical in the book. A couple of those definitions, I've known some of this stuff since the first started hearing about relational databases in the 1980s. And on a couple of those technical definitions, I was like, what? So I did the English version for the vocabulary, ease into some of that technical term. Also got some stuff for history, and I did I did get a second, at least one edit on that setup assignment for the one I was going to use. The online state shell, I believe I mentioned the other day, I kind of ended up with this last minute moment. There wasn't anybody to teach this course, and I couldn't find anybody to teach the course, so I put my own name on there when I was making the schedules, and that kind of happened at the last minute. So it was a rush to get in there, and it started as the Ivy Online shell, but like I mentioned the other day, expect edits, so don't work very far ahead. Y'all probably noticed those discussion board topics. If you look through there, there's no room for discussion. Just asking you to go look up a bunch of words. How can you really talk about that? So those will be edited soon. They use Oracle Apex, which I've used a couple times, but it's not the one that I use over and over and over again on my own projects. Which the one I use over and over and over again on my own projects also happens to be the one you will see most commonly in the world. It's the one that WordPress and kind of by default extension, Wix and Squarespace and all those easy to build websites applications, those all recommend the same one. So we're going to use that one because pretty much any free domain host has it. It's really easy to set up. I recommended a virtual server in there that is cross-platform. I almost always have it running on my Windows machine, my Chromebook, and I don't bother to put it on a Linux machine because it's a virtual Linux. But XAMPP is the name of it, XAMPP. So sort of a LAMP full stack named back before they dropped the second P. In 2023, we usually only put one P at the end there. But on setup assignment, there's some step-by-step stuff there. You can download the PDF if you don't want to stay logged on to Ivy Learning the full time, but took some pictures. So free domain host, for those who had me in like something where we've used that before, last semester, the first 8 weeks in the web development class, I used the same one here, which this is affiliated with a big hosting platform that uses, I always forget their name, but their logo is the blue alligator. So very popular one. A lot of people recognize that. But this is the free one that is associated with them. And somebody had the wonderful idea to show ads on the back end as well as the front end. So those ads on the back end pay for a lot of stuff that other free domain hosting sites don't have, including lots of databases. Some of their ads say unlimited. Technically, it's 400 databases. I think you can fill those databases up with as many tables as you want. And, whereas most free domain hosting sites give us one database to work with. So get a lot more stuff. There's step-by-step there, or a local virtual server, which I consistently run on my PC, Mac, and Chrome. The X stands for cross-platform. This one's been around for a while. Very popular. And I also thought if you're interested, probably I'm gonna go ahead and do this now. Let's kind of start talking about a database, what it is and stuff. So I want to do this before we look at goodies. If you did not know, Windows now includes virtual Linux machines. Or said that backwards. Linux virtual machines are included in Windows. If you have not encountered that yet, as long as your machine's up to date, just let it out. As long as your machine's up to date, I believe it's like you can check the update number, the build number up. As long as it's after 20.19 on Windows 10 or any version of Windows 11, Linux virtual machines are built into the Windows system. It's called Windows Subsystem for Linux. Actually, you can just type WSL-install, and that will give you a virtual Ubuntu machine. There's a better way to do it though. This one you have to restart your computer, but if you go to the start menu and search for turn Windows features on or off, anything on this list you have to restart your computer to do. But down at the bottom you'll see Windows Subsystem for Linux somewhere on this list. Oh yeah, you just hit that check mark, and after you restart your computer, it will be installed on there so that you can go to like Microsoft Store. Probably right there, yeah. Go to Microsoft Store and just download a version of Linux to install there. And it's not quite like a virtual machine. I know this is a 100 level class, so the next thing I'm going to say may confuse people. In the chat room, when did that happen? It's been working in for a while. So they had WSL for several years and kind of beta testing mode, and they updated to WSL2 version 2, and then they started promoting it. It's in every version of Windows. From if you go to settings, so like our system, there'll be a build number showing your latest update. Somewhere in there, I thought. Maybe that's not where it was. Okay. Oh, yeah, there it is. So there's under system and about, there's OS build. If you're on Windows 10 and it's 20.19 or 2019 or later, it will be on there. So it's been around for a while, and it's not. Go to store, Microsoft Store, look for Linux, and just install the latest version of Ubuntu or Kali or whatever Linux system you like. And it's not quite like a virtual machine. If I come over here to all apps, this one, some of y'all, since it's an introduction class, might not recognize it. Notice the Kali Linux stuff is in the start menu. Where's something I can start here? Just, oh, thumbnail. If I start this little application, oh wait, I probably should have started that virtual machine. I have to spin up the virtual machine, but then you'll notice that is clearly a Linux file explorer, not the Windows file explorer. So the Linux apps run native on your machine. I close it. Yeah, that's weird. That actually closed it. Okay, I don't know why that wasn't closing, but it usually works pretty well. I'm going to reset my Ubuntu machine. And when you have it on there, this is how you completely reset it back to a brand new machine. So, whoops, WSL-unregistered Ubuntu. There we go. So now I have a a brand new Ubuntu machine here. So I want to show this, the step-by-step instructions I wrote. You can go to the domain host and set that up. But I thought I would take a moment and show you what that virtual machine is setting up. Entering the password, and so here's the instruction. Here's the line-by-line instructions to do this. So if anybody wants to do WSL, 18 lines of code to set up a LAMP stack, which is in some ways quicker than downloading an installer and stepping to the wizard on an installer, if you know all those 18 lines. If anybody wants to do the WSL way, I can just send you this file. This just checks to make sure you're in the most updated version. Install Apache so that we can access the server through a browser. PHP, we could probably bypass this stuff in this class, but that's an important part of the LAMP stack. The scripting part of the full stack. And then we want the MariaDB is one version of MySQL. When the guy created MySQL, we're going to talk about the history of databases in a moment. It's an electric parts. When he created it, he actually made two. One of them is commercial, costs money and stuff, and the other one's fully open source, and he named them after his daughters, Maya and Maria. And Maria is the open source one with more features. He spent a whole lot more time on that one, and the one that costs money seems to have less features, and he clearly spent less time developing it. I always thought that was just kind of an interesting side note. But then a couple other things that we need to have installed, and then down here, since a version of MySQL was installed, we need to create at least that root user to have minimal access to. That script right there, that's well, there's white space in there too, so those 18 lines will get we'll run that. So I'll go over there and grab that. And or I guess you can also see here that Linux virtual machine is in my Windows File Explorer. So it's a virtual machine, but it's fully integrated into Windows. Would this make using Docker easier for Windows? Not necessarily. It's the same. It's exactly the same. You would write the same Docker file in both cases. Some of y'all probably have no idea what a Docker file is. You would write the exact same Docker file, and Docker would automatically create virtual machines in both your Windows system and your subsystem. So Docker would handle everything. It's the exact same file. You wouldn't have to do anything. So in the chat room, comments that for those who know what Docker is, very quick performance of Docker is bad on Windows. Yes and no. Part of that comes from programmers used to taking full control over the Linux machines. So when a lot of processes are automated, they mess up the automation by doing what they're used to. But not doing that is going to throw the typical programmer off. So that's an important thing. So a little side step there, but for those who haven't had me in class before, feel free to ask questions if you're curious. Right? We can go down rabbit holes and talk about what you're actually interested in. It was hard to put that, it was hard to know your actual interest before class started when I was setting this up, maybe before you even registered for class. Not in this one because it was set up at the last minute, but I don't mind going down those little rabbit holes and following your personal interest. The quizzes and things like that will be based off the textbooks and videos and all that stuff that's already put in I've learned. So if our lecture time goes to what you're personally interested in, it's still beneficial, right? It's still doing all the quizzes and stuff. So I'll just copy that shell script. So you just copy that over to the thing. Or if you have a regular Linux machine running, if you had the the cloud classes, cloud administration classes. And want to spin up in EC2, you have to make some slight adjustments, but if you want to do that, you would know what word from that text file. You'd have to change everything that says app to yum. And if with yum, install goes after the things you want to install. But if you spin up an Ubuntu server on AWS, it would be that exact same bash script. Or if you have a virtual Linux machine, it would just load in there. Or if you're a Linux user, it's that script. So I don't have the right permissions since I copied it from a Windows machine. So I need to change that to 755 is usually good. Spin it.sh. And now if I run that, it's going to do a whole bunch of things. It's it's a brand new install of Ubuntu, so it's got to do all the updating. Shouldn't take too long. But while that's going, and quickly do the history part of the lecture. You know, a whole bunch of stuff's going to go spin past as it does all those installs. There's one spot where I have to enter click yes or no and things that I left the automation of it out of that script. So you do have to enter, select yes or no twice and enter a password and confirm the password on the installation, but pretty straightforward. So first off, let's look at the history of databases. History of databases or databases. I believe I mentioned the other day, data is actually a Latin word. We use it the same way the Romans did, but we're not speaking Latin, we're speaking English. So data or data, that question often shows up when people are starting into courses like this, and either one is acceptable in our world. Database is not a Latin word, and that database, however we say it, in America, we often pronounce all three A's differently. So there's wiggle room in how you pronounce it. Everybody in America, or everybody in the modern world, is going to know what you. That's a question a lot of people have. But data is a Latin word. So datum is a single data point, but we don't really use that one very often. But does anybody believe the data is a new concept? As mentioned, it's a Latin word. We still use it the same way the Romans did. That which is given, the raw facts themselves. So ancient need, we could trace it back to prehistory, do some stuff, go way back there. Before we get too far into this, here's those two little boxes. So along the way, I didn't automate this, so we have to. It's one of those old style where the mouse doesn't work, so it gets space to select it, and then enter to accept it, and then here in a split second, it's going to ask for a password. So I'll type that in, and then we'll get to the lecture. Yes, do the default one. And the password here is for the system. This is so your operating system can access the database. This is not even your main database administrator usage. This is the password for the operating system to access the database. Okay, and then everything else is automated. So we'll look at that here in just a second. So you can see it didn't take very long for that script to run. Actually, probably quicker than downloading an installer and setting it up. If you're heading into IT, having a Linux virtual machine to work with is very, very useful. Okay, so obviously there's been a need for a long time. And pull up some old pictures. I always point these out in the Informatics 109, so it's kind of fresh on my mind. Actually, just searched for it a couple days ago. These are ancient things. 3,000 or 4,000 years after these were made, the first foundations were laid in cities of Jericho and Jerusalem. So that region, for thousands and thousands of years before anything we can even begin to put a name on. And obviously those earliest foundations probably had a different name, right? A long time ago. But they have these little clay balls. It's hard to see in some of them, but they would have different shaped stones and different colored stones in them. You can kind of see it on here. They would put reeds and grass in there, make specific breakpoints, usually that crossed over an image, so they could tell if anybody had tampered with it. We have no idea what it means. The general basic ideas is probably something like common grazing ground, shared grazing ground, until which sheep belong to which shepherd. But most everybody will look at that and can tell you that meant something to the people that did it. We don't have the context, but that's some early data. And other stuff along the way, cuneiform tablets. So I don't read cuneiform, so I can't point at a particular one and say which one it is or not. But there is a large stack of cuneiform tablets that are indexed data, just like we would make a list. It has number one, has a person's name. I'm not going to try to pronounce the Babylonian name. They usually had lots and lots of syllables. It had their land holdings and a whole bunch of data with it. Index, so number one, number two, number three, everything put in columns, looked exactly like the tables we draw out today. Just written in cuneiform instead of our language. I don't know which one of those tablets it would be, but I'm sure it's probably one of those that's on the images when I pulled those up there. Obviously, writing like we know. Libraries got quite large, so library Dewey Decimal System. So before electronic stuff, there was this integrated card system in all the libraries to keep everything organized. You would know exactly where everything was. Most of y'all are probably too young to remember that. I learned about starting back in elementary school, learned how to do that. And I remember when the Dewey Decimal System was on the library computer, that transition between them. But eventually we got to electronic stuff. And that's the part we care about, right? Studying IT. We're familiar with those things. The main point there is it's not something new. It's an ancient need of humanity. We just have a really, really good tool for it. So with early computers, obviously the task was assigned very, very early to computers. Very early in computing. We would use flat files. One of the words we talked about the other day, where we think of it like a text file. Set up a text file, write all your data in there, and the computer can search through it automatically. It worked. It was a lot quicker than digging through the library manually. Worked, but could be better. The biggest thing on that could be better is every search has to start at the beginning. So if we need 3 things from those files, we have to go to the beginning of our entire collection, start digging through until we find the first thing. Then we have to go back to the beginning and dig through until we find the second thing. Then we have to go back to the beginning and dig through until we find the third thing. So 3 things basically required 3 passes through the files. If we happen to need the very last 3 things in that collection of data, it would require 3 full passes to find all 3 of them. So what we needed needed things that were faster and expandable. Because obviously, if all we have is a bunch of files, any extension means creating more files. Or at the very least, editing those files. It's not easily extended. How much of the board is the camera showing? Okay, there's a number in there. So early to mid 60s. IBM created the information management system. I'm going to put here release 1966. So the full testing's finished, full commercial release, all the banks need to buy this system immediately after 1960. So obviously there was at least 6 years of testing leading up to that. But that's the information management system. Missed on the video, yeah. Or IMS. We actually still see that in our modern world. By IBM. It does still exist because it's a good organized structure. What it is hierarchical. Parent, child relationships. Oh, wait. I don't want to use the word relationships. So parent-child connections between banks. I'm going to write files because it is still basically the flat file structure. But then I'm going to cross that off and write data because it progressed a little bit further and kind of switched into other formats that we wouldn't necessarily call a file in our modern world, something more like tables. But I think somewhere in the notes, probably in the second set of notes for today, there's a little distinction of what file means to the computer and what file means to the human is not necessarily the same. Slight differences, a small sub point, but when you're reading through a technical textbook about databases, that small sub point can make a difference. Later, GE improved it with multiple parents per child. So we have, I'll draw it up like files. So we have sort of a hierarchy structure. And the parents in that hierarchy point to the child. So then we don't need the whole file. We can go through from pieces of the file instead of the whole thing. I'll do this in red. So GE came back and allowed multiple parents per child so that we have more than one route through. Maybe something like that. Which basically gives us more than one route, but from that picture, you can already tell like it's very, very complicated. Very, very quickly. Somebody's really got to know what they're doing to follow all those different pointers to get through an IMS system. It faster, but it took a lot of human maintenance And that human maintenance, well, it had to be somebody specifically trained from IBM or GE in order to do that. So it was also very, very profitable for them because it wasn't just sell the product and the customer would use it. They sold the product and was like, here, buy this database and we'll have our technicians stop by once a week and make sure everything's working for you. So very, very profitable for them. So then a couple of years later, somebody came up with a better idea. It's okay if I raise the first slide over here. That way I don't have to keep trying to move the camera and stuff. I may have to find a spray bottle when we take a break because it's this marker is hard to erase. Just scrub that. Okay, so in 1970, a fellow by the name of Ted Cobb, Cod, like the fish. So Ted Codd proposed the relational model. That's the one I'm going to draw pictures of the other day. Each data point gets its own field or cell in the table. Related fields are connected into rows or records, will be our technical term. Related records are connected into a table, and related tables are connected by common fields, or tables are related to common fields. So there's lots of relationships everywhere. And instead of those big files with lots of data in the file, everything basically becomes its own data point. The one we drew a picture of the other day, the thing we're going to study the most in this course. You tried to promote it, but it was not going to be as profitable for IBM. Well, I already erased it, but remember I had that note here. We needed something faster and expandable or scalable. Once we have tables, I'll just kind of draw some generic tables. Tables scale vertically. Right? We can add rows to that table all day long. We're not adding any more columns, not defining new columns. So if we're just adding more records, we can do that all day long. So tables scale vertically. I'm going to write that in capital letters because that's a big difference from this. Right? With those arrows, I barely drew any picture. I barely drew any boxes, and look how many arrows we ended up with. Trying to scale that would be an awful mess. That's why it was so profitable for IBM, because any changes required the professional technicians to come in from IBM and do a whole bunch of stuff. Scale vertically. And that way you can, instead of just seeing the word scale vertically in a textbook and be like, what's that for? Think about if you draw a table, you add rows, that's just, you're making that table stretch out vertically. Doesn't do much horizontally. Adding more columns to that table is kind of a problem. If we add another column here, I'll go to green. If we need to add another column here, we have to add that column all the way down through all the scaling we've already done. So scaling horizontally can be a problem. But scaling vertically, relational databases are great for that. It definitely would not have been as profitable for IBM. Pretty sure there's or I saw it in the textbook. There is a history section. I didn't read their history section, but I feel quite confident that they left off the part about profitability, because textbooks often do that. They would have talked about, oh, this change happened. Well, the idea came out in 1970, and he started trying to promote it. And him and a couple other guys started with one other big guy named IBM, because the company wasn't liking it. Like, oh, that's gonna cut into some major profits. It's okay if I erase this side. Got some more notes. But that's a big deal. They had a better idea, but nobody was listening because IBM and GE were making fortunes. And it would have definitely interfered with that. Textbooks always leave off that little subtlety there. It's something that does still happen in our modern world too. Not to the extent it did between 1970 and 1973. Because he also worked for IBM. And he was an engineer. He sat in an office and did thinking. So when he thought of this idea, sitting in an office getting a salary for IBM, just sharing the idea became a problem because it cut into IBM's profits. So it was 1973 before anything else happened. Finally, management changed around a little and they finally slacked off. And where was it? Did I write names down on this one? I didn't write names down, but researchers at Berkeley I was at Berkeley College in California, not the one in Massachusetts. The computer scientists, not the musicians. They implemented it. They finally made a fully functional version. Things just like opened up that IBM at least gave permission that even though that engineer came up with the idea while he was on IBM's salary, they would let other people do it. They weren't going to block the idea. That was IGRIS, relational database. In 1975, IBM finally followed through. IBM made System R, but didn't promote it. I guess I can put it here. There's only one more note here. They didn't do any promotions. They're finally like, okay, this was our idea. We're going to make it. So a stable one had been invented. So IBM created it, but they didn't market it. They didn't do anything that made them lots and lots of money. Oracle was founded. Another one of those companies, late 1970s, people are excited and interested about this. So the guys just put up a bunch of their own money and started doing it themselves. Which theirs was fully commercially available. Starting in 79. So it took them 2 years to get it going. But in 1979, they had one fully commercially available. All you had to do was buy the software. You didn't have to go sign a contract with IBM or GE. And you didn't have to go through all sorts of big, huge steps. You could just buy the software and install it on your machine. On at first mini computers, but then as machines took off in the 1980s, Oracle kept up. At the end of 1982, like November, December, IBM finally tried to release the commercial product. They did some updates and tried to release an updated version of this thing. But by that point, Oracle was firmly established as sort of the king. They were never greedy with their stuff. I just installed an Apache server. Y'all probably all heard the name Apache, right? Oracle owns Apache. Apache is a subsidiary of Oracle, and it's a very special one because every single person that works at Apache is a software developer. Apache is only programmers, except for the few that got promoted to management positions. So it's a subsidiary of Oracle that is still fully just like those original two guys sitting that were interested in programming and started doing it. So even though they've expanded into lots and lots and lots and lots of other places, they've never lost their roots and stuff. The Ivy Online shell still uses using Oracle databases. I very rarely use those on my own projects, so I was a little bit worried about how quickly I could answer questions. MySQL came out quite a bit later. When was MySQL released? I didn't include the dates on that. When was MySQL introduced? 1995. So by 1983, or 79 to 1995 saw steady improvements on databases. That's when MySQL came out, and then MySQL is one of the most popular. It's based off of Oracle's. Pretty much all relational databases are based off one of these. SQL Server is based off the System R, with some stuff from Ray. It's kind of this, but a lot of the iGress too. So SQL Server, and then Oracle, and then most everything else is based off one of those. So MySQL is 26 or 16 years of improvements from what Oracle created in between 77 and 79. So that's the one we're going to look at. Okay, so I copied that script over here. If anybody wants that, I will send that out in an announcement. 18 lines to do that. And this is what those virtual servers are doing. On that domain host, it's already set up for you. And on that Jamp, it's download a virtual server and it runs. Either one of those will work, but really what we're doing here is running, I guess before I hit enter, notice where I stopped the history here. Like, it's been updates since then, not drastic changes. That's way before GUIs. Some people might have had the idea for a GUI, but computers in 1979 definitely couldn't handle that. So I wanted to look at some stuff here, or this real quick, before we look at any with a GUI on it. Remember, it is these instructions. So for like software developers, the actual database stuff is instructions we put in one of our terminals. If you have Jamp installed, you can access it right from here. I'll show you that later. It's these instructions. So when you write a piece of software, you can pass this instruction to your operating system just like you can any other instruction. That's what a software is. But for software developers, you're going to access this directly. Pretty much everybody's going to do something with databases, right? Data analysts are going to do a lot because big data is big money in our modern world. And an exact equality, big data equals big money. So data analysts are going to do a lot, but everybody's going to do something with data, right? If you're a network infrastructure person, you're going to at least need to keep track of all your users and their access privileges and all of that. So everybody's going to do something with it, but it really is these instructions that we pass into a terminal, like show databases. End of instruction. Semicolon means end of instruction. I'll try to read that as we look at stuff. So, well, you all saw just a few minutes ago, I just completely reset Linux and did some stuff there, or completely reset it and then installed that fresh. So it comes with this. So information schema. Schema is, but think of it as your design, but more explicitly, it is the code you write to implement your design. Is the schema. Your final project, you have to turn in a schema. You'll write a bunch of SQL code, but when I go to grade it, I will go over to MySQL database and run that code you submit, and it will create the database you designed. That's what a schema is. It's actually, well, there's some definition stuff coming up. We'll see that in a moment. And then we'll do some stuff. So let's do preview real quick before, and then take a break, and then we'll get into the definition lecture. Beginning of the semester, we got to do the definition lectures. So not the most interesting ones, but it's the words we're going to be using throughout this semester. So we need to make sure we know what they mean. Our book is very, very technical. I've known some of this stuff for a long time, and had to pause on a couple of those definitions. Like, what are they talking about? So we'll look at the English version. So I'm going to create a new database to use. I don't know, I'll call it opinions. End of instructions. So create database. So this is the stuff that we're working with. Create a database, call it opinions. And then I'll say use opinions. And there's no clear when you're in the database. I've been known to like exit the database and go back to the regular terminal where there's actually a clear function just to get back to the top of the screen, but I'll skip that for now because we're in preview mode. So we're going to use that database we just created. Let's say show tables. There's no tables to make, so that's the first thing we need to do. We need to create a table. I'll call it people. Let's say person ID. We'll need a unique identifier. We're in preview mode. We'll talk about why this is important soon. Person ID. So the unique identifier. I'll just do an integer. Auto increment it, and it needs to be a primary key. Maybe there's a name, which would be text. Age, also be an integer, and town will also be text. So I'm going to create a table that looks kind of like that. Okay, and notice the return. We get a result back, 0 rows effective. So as heading into the software development, you get a return. There is a return every time you do that. 0 rows could be good because we might not have actually changed anything. Might not have affected any rows like here where we just created a table. But a negative number means something went wrong. So a negative, if you get something negative there, it's an error. And we're going to see this in a GUI before long too. So then we have nice labels everywhere, even and predictive text when we type the SQL code directly. Let me create another table. Create a table called fave food. Again, need a unique identifier, so I'll say food ID. I'll just make it an integer. Let the database handle that. Make sure it's always a unique number. It'll just keep counting forever. I'll say person ID, integer, and food text. So I have 2 tables now, and I can insert some data into it. So insert into people. I don't need to deal with the ID because I already asked the database to do that. Auto increment the numbers and just keep giving us integers 1, 2, 3, 4, 5. That way there's always something unique for every record in our database. And we're in preview mode. We're going to talk about this in detail and why we need to do that before long. So I need to get into the name, age, and town fields. Then some values, and this is one we will do a lot of. Create a table, then insert into that table these fields and maybe some random values. I'll just put myself in there. Chris, 44. I live in Clarksville. And insert into that fave food. maybe I shouldn't use my own data. I'm not very particular about food. I'll make something up. So what do I need? So I need person ID and I forgot what I call it. Oh, food. Food, the values. Oh, hopefully that should be the unique identifier person number one. There's only one thing in there. I don't know, hot wings sound good. So now if I come back over here, show tables, see we got a couple tables. I can select all the data, select everything from people, where one, so where is the condition, and one in this case being true. Where zero would be the same as saying where false. And then we wouldn't get anything back because every condition would be false. So here, this is just saying select everything from that table where the condition is true, which just automatically assign true to every possible condition you can check. We'll see that stuff later. Right? Whether age is above 40 or name starts with the letter C. There's not a whole lot of filtering we can do with one data, but we'll see that stuff. We're in preview mode right now. And it gets us our data back. Or we could select everything. So that's the wild card. The asterisk is complete wild card. Just whatever characters the computer can find that will fit in there and not crash, it will fill that in. We also can do it with a question mark. Like if something is misspelled, a question mark is one character. It's like, okay, I don't know what letter goes here, and it'll fill in that. Question mark also gets used in more than one, can be used in more than one place depending on where we type it. But as far as wildcard selectors, which by the way, all search engines know the asterisk and the question mark as well, if you're not quite sure what you're searching for. So select everything from food or say food. Again, where one is in 1, 0 and true, false, where every condition is met, and we get all that data. It's long been erased from the board, but that's the early stuff, right? It's like, oh, we have a data set. Let's look at the whole thing. We can do much better than that. So last one from the preview section here. So maybe we want to select people.name, people.age, that's lowercase. It is the stuff we name is case sensitive. The SQL keywords are not case sensitive, but it is convention to write the SQL keywords in all uppercase. That really throws people off sometimes at first. The stuff in the language is not case sensitive, but the stuff we name is case sensitive. And fave food dot food from people joined with the fave food table. Where one, I can add more filters in there, but I mentioned the word join the other day. Join means to search multiple sources. In our case, it's going to search through multiple tables to find that data. There's more than one acceptable syntax. I don't think our book shows this syntax. This is the one I prefer because I write a lot of object-oriented programs. So I'm used to the dot operator. So I kind of like this syntax, but when I do that, I get just the data I wanted from those two things. Very, very quickly. It didn't take long to search through the entire data set. We had a lot more stuff there, right? Pull up different names, and we filter our data down. And the important part is that data is over on storage. To get it to print out on the terminal, I have to move that back to RAM, right? So that was what that diagram drawn the other day on Tuesday about I guess still in preview mode, was about, we don't need our entire data set. All we need is, we need to know the starting point, which in our case, the starting point was all conditions are met. Just go ahead and assume everything is fine. And then we need to know the ending point. So the people grab that stuff from the people table, follow relationships around, grab that stuff from the people table and that stuff from the food table. Let me do one more for preview mode. So I need to insert some more data. We can copy this. Oh, yeah. I'll copy this insert query and then make somebody else in the database. Let's say, oh, yeah. In the terminal, tried to act like I was in a regular text editor. Hey, Sally is somebody who's 23 from Salem. We got that in, and then insert into fave food. What did I insert in the second one? Person ID and food. Person ID, food. So insert into these columns the values 2, because we only have 2 things right now, and maybe a cheeseburger. End of instruction. So we get that, and if I hit up and run that same query, I'm going to change this condition where people.age is greater than 40. So now it's not all conditions are met. Only half of our data set's going to fit with this, right? And we don't need all of the data that's over in storage. It'll automatically grab those 2. I found 2 of them because it looked at 2 records. There's ways to get rid of the duplicates and stuff, but I forgot something. It found that from the people table, but it still looked at the other name. So here I need to do and people what was the ID called? Person ID is equal to fave food dot. They have the same ID, yeah. It's very common to rename those. I never do. I find it confusing. I always keep the IDs the same as we go to different tables. But it's actually I've never heard it explicitly stated when people list out conventions, but it seems like convention that people rename the IDs when they go to a different table. And I find it confusing. I keep them the same. But oh. Too many equal signs. There we go. So it filtered down and found just the data we wanted from the data set. And that is in the transition from storage to RAM. So even though we have those 2 tables with 2 records in them, and however many total, 1, 2, 3, 4, 5, 6, and 7 total columns between those 2 tables, only these 3 columns and 1 data point in each column made it back to RAM. So we're not being wasteful with our resources. RAM chips have gotten really, really big, right? We have lots of RAM, but we have lots of data too. There's 7 billion people in the world. We have, or so with Americans, 350 million Americans, and we could easily probably find 500 megabytes on every single one, 500 megabytes of data on every single one. We'd be hard pressed to get that into a RAM chip, unless we have some very, very, very large, powerful machines. we can still overload RAM with like modern data sets. So when the data stays over in storage where it should be, and we only bring into RAM the part we need, our machine can do more. Because there's also this. If I open, go over to Task Manager, my database is not the only thing running on my computer right now, right? At any given time, there's a long list of software running on our computer. And if our stuff starts to interfere with other stuff that's running on somebody's computer, they're going to notice it pretty quick. So there's good reasons to still do that. And sort of preview mode there, but see how we're typing those instructions in. Some of you all might want to type those instructions in. So if you know those keywords, it's a lot faster. Right? You got 120 buttons on the keyboard versus 2 buttons on the mouse or something. If you know the right words, and if you know the right order to press the keys in, that's going to be faster than anything else. But we have other ways to do it, and we can look at that after the break. Oh, and then type exit when you're done with the database to get back to the regular terminal, which I often do along the way because then there's clear command and I can go sudo MySQL. I'll often do that and jump out of the database and back into it just so I can clear the screen. But that's personal preference. For some reason, I don't like working at the bottom of the screen. And when you're having MySQL open in a database, it kind of fills up the whole screen. So I will send this one out to you all if anybody wants to just do that directly in the Linux machine. If you install Jam, I guess I can show you this real quick. So to open the terminal, I hit Windows X, and then I opens the, Windows X, and depending on your system setup, if you haven't upgraded to the new Windows terminal, this is, every once in a while, Microsoft does things just amazingly good, and it's easy to remember why they're at the top of the chain. This is by far one of the top examples, Windows Terminal. You notice have all the terminals in one place, different tabs. They run consecutively and can interact with each other, fully customizable. It's great. So if I change to C:/jam, here's that virtual one I said to install. Okay, so then change into the MySQL folder. And then the bin folder. And you can set up a shortcut here, but right here is where MySQL.exe is. So you can just run that from here. MySQL -h is localhost -u root. Oh, whoops. It's a file. I don't have it. If you have it set up as a shortcut, you don't have to put the // which means look at the current directory and run this file. Run MySQL on localhost and use root user, and the default password is a blank string, so I'm just going to omit that. There's a -p as well if you have a more secure password than I do. Oh. This is in the instructions. We do have to actually start the MySQL server and the Apache server if you want to go through a website. Let's clear all those error messages out there. I usually set it up with the shortcut so I don't have the extra steps and automatically start it every time my computer starts up. But I also do factory resets every single between classes because I will regularly break computers trying to show you all stuff. I don't mind breaking it. I know how to fix it. My phone's currently broken. I don't have any cellular data, and I can't. I guess I shouldn't have had access to the Android kernel. I'm not really sure how I had access to the Android kernel, but I got it. And I broke my phone. But it still works for text messages and phone calls. That's the important part. Oh. Sorry, I'm ready for a break. Local host, there we go. And then we're right into the MySQL database that we just saw on the Windows machine. So for those heading into data analytics explicitly, maybe also the software developers, you might want to get some practice that way. Because software developers, you're going to write this in your software. So get some practice with the SQL code directly before you have a Python script write the SQL code for you. Make a big difference. And network administrators, server administrator people, y'all are going to spend all day long on a terminal. So if you've got your users in a nicely organized in a database or something, you might want to get a little bit of practice. In short, getting some practice there will be useful for everybody. We're still in preview mode. We will see more of this stuff later. For now, it's probably a good time to take a break. 10 minutes sound good to everybody? I'm starting to make silly typos there at the end, so I'm definitely ready for a break. My laptop says 2:10. We will get back to it at 2:20 on this clock. See y'all in just a moment.